In this video, we are going to look at the eye. So first of all, we need to look at the specifications. This is 2.91 and 2.92 of the IGCSE course. So we need to describe the structure and function of the eye as a receptor and understand the function of the eye in focusing on near and distant objects and in responding to changes in light intensity. So first of all, we're going to look at the structure and the function of the eye. So the white outer layer is called the sclera. The lens is that elliptical shaped object. Then you have the iris. The black hole in the middle of the eye is called the pupil. And the outer transparent layer is called the cornea. Then we have ciliary muscles along with suspensory ligaments, which were in green. The inner area is the retina, and you have that little dent is called the fovea, and we also have the blind spot where the optical nerve attaches to the back of the eye. So first, the tough outer layer of the eye is called the sclera. At the front of the eye, this becomes transparent, called the cornea. Behind the cornea is a coloured ring called the iris. So this is what gives you your eye colour. In the middle is a black hole called the pupil, which lets light through into the eye. The lens converges light to the fovea. So it focuses light to the fovea or anywhere along the retina, but the fovea is the most optimum point. This is held by ciliary muscles and suspensory ligaments, which control the shape of the lens, therefore adjusting its ability to focus. You want it particularly to hit the retina. The back of the eye is called the retina. This is where the light-sensitive receptors are located, and this is where light energy gets converted into electrical impulses, and it's done by rods and cones. Rods work well in dim light to produce images in black and white, whereas cones work well in bright light and produce coloured images. Cones are found in concentrations in an area called the fovea. So they're found in high concentrations there. Rods and cones produce impulses via sensory neurons and travel to the brain along the optic nerve. Where the optical nerve attaches to the eye, there is no rods and cones to be found. Therefore, no images can be produced here, and it is called a blind spot. A reminder that any images that go into the eye, when they go through the lens, they flip upside down, and it is your brain that flips them back again. So, how does the eye protect itself? The first thing that it has here is an iris reflex. So very bright light can damage the eye. Bright light triggers a reflex to make the pupil size smaller. So this is an automatic reflex. Here you have the circular rings that I've highlighted in red are circular muscles. And when bright light comes in, it causes these ciliary muscles or circular muscles to contract. This makes the pupil smaller. So when bright light comes in, these circular muscles contract, making the pupil size smaller. In dim light, however, the opposite happens. This time, the brain tells the radial muscles to contract, which I've coloured in green, causing the pupil size to increase. So, the next thing we're going to look at is focusing. One key word for here is called accommodation, and is the ability of the eye to change the shape of the lens to focus light on the retina. So a reminder that the lens in the eye is convex in shape, and you want to focus all them light rays to a certain point, and that is where an image is formed. Ideally, that point needs to hit the back of the eye along the retina. So focusing on far objects. Just a little reminder of some parts of the eye. I've coloured in yellow here the lens. The pink is the suspensory ligaments, and the blue is the ciliary muscles. So when an object is far away, the ciliary muscles relax, okay? As they relax, the suspensory ligaments pull tight. So as you can see here, they'll pull tight, and this makes the lens go thin. So I've just slightly changed that image there. It's changed the shape of the lens to make it thinner. Still convex in shape, but much thinner. So it refracts light at a smaller amount. So it's not good at refracting light, it refracts it less. It still can, but just less. So as light comes in, you can focus on the back of the eye. So a key point is here that for focusing on faraway objects, the ciliary muscles relax, so suspensory ligaments pull tight, and the lens goes thinner in shape. So how do we look at objects that are near to us? Here, the ciliary muscles contract, which slackens the suspensory ligaments. As you can see, compared to the previous diagrams, you see a lot less of the suspensory ligaments because they've slackened. This makes the lens become more curved. Its ability to refract light is much stronger now, and it can focus the light, therefore it can refract it more to the back of the eye. So, some conditions with the eye. The first one is short-sightedness, which is called myopia. So the above diagram is an uncorrected lens. As light comes into the eye, ideally it should hit that X that I've drawn. However, that intersection happens too early, so it doesn't reach the X, and the image is formed at where them two lines cross over. This should happen on the X. So, people with myopia are unable to see distant objects. The cornea or the lens bends light too much, or if the eyeball is too long in shape. Okay. To fix this, it requires a concave lens, which I've drawn. This time, the light comes in and hits the lens, but it has slightly scattered the light, or refracted the light before it hits the lens, allowing it to focus on the X. So the key point here is that for short-sightedness, it is fixed by concave lenses. They disperse the light slightly so that when it comes to the lens, essentially making the lens less refractive and allowing the light to be focused at the back of the retina. For long-sightedness or hypermyopia, this time when light comes into the eye, the image is formed behind the eye. People with this are unable to focus on near objects. The lens or the cornea doesn't bend the light enough, and the eyeball is too short. It can be either or. To correct this, you need to add another convex lens in front of the eye. When light comes in this time, the two lenses work together, strengthening the lens in the eye and therefore making it more refractive, and it can bend the light easier, moving it to hit the back of the retina. This time, long-sightedness is fixed by convex lenses. Hopefully this video is of some help to you.